This question gets at the notation for composition of functions, and really this is just a matter of reading this the correct way. The function that you see here, g circle f, which we read g of f, just means the composition of g and f, where we're chaining together the action of the two functions. The reason it's written in this order is to suggest the order of evaluation. When we evaluate composition of functions, we always work inside the parentheses out, and so that makes it feel a little bit backwards with the notation, because that means we're really doing the f function first, followed by the g function. So the reason that it's written in that order is because of this idea of working inside the parentheses out. So we have to do g of f of negative 1. That means we need to first work out what f of negative 1 is, and that'll go here. And this working inside the parentheses is consistent with what you always do when you're evaluating things in mathematics. We always work inside the parentheses first. So f of negative 1 is negative 3. You can see that from the definition of f. F of negative 1 would be twice negative 1 minus 1, which is negative 3. So we know that f of negative 1 is equal to negative 3. So g of f of negative 1 is the same as g of negative 3. And now we can compute g of negative 3 by using the rule for g. Oops, didn't mean to write that. The rule for g is here. And I see there's a typo. There should be a y. The rule for g says you take the input and add 1 and square it. So if we add 1 to this input, we'll have negative 2. And if we square that, we'll get 4. So the answer here is 4. So we'll do it one more time with this other one. F of g of 2 can be better written as f of g of 2. Once again, we're working inside the parentheses first. So I first have to figure out what g of 2 is. G of 2, again, the action of g is to add 1 to the input and square it. So that's 3 squared, which is 9. So f of g of 2 is the same as f of 9. And now we can evaluate f of 9 using the rule for f, which is twice 9 minus 1. And so that's 17.